Welcome back, and today we're going to take a look at dimensional analysis. And basically, a dimensional analysis is going to permit us to convert one unit to another one and still retaining the original value. So, for example, if I said I have 5 minutes, that's going to equal 300 seconds, and those two are equivalent. They're equal to each other. But sometimes we'll want to convert from minutes or hours into seconds, and we have to have a means to do that when it's not just a real simple one. All right, we can write any conversion as a fraction. So for example, we've got the conversion that there's 60 seconds is equivalent or equal to 1 minute. So we can either write the fraction as 60 seconds over 1 minute, like here, whoops, like this one right here, or 1 minute is equal to 60 seconds. Now notice that on my fractions that I had my the fraction where it's got the horizontal line. If you write your conversions, oops, oh shoot, hold on a second, let me get the right tool. All right, so I need to have, there we go. So now if I write it like this on a piece of paper, it's going to be a lot more confusing. If you write 60 seconds, 1 minute, it won't always be so easy to identify which a unit is going to cancel out. So I would suggest that you set up your fractions like this when you have it on a sheet of paper. Obviously, when you're writing in a text box, we're not going to have that luxury. We've got our ratios, the two different ways we can set up our ratio. And so now let's take a look at an example problem. And we want to convert 2.25 minutes to seconds. So the first thing that you need to write down is we need to write down what you were given. And I'm given that there's 2.25 minutes. And including the units will be really important. Now we need to set up our ratio, our conversion factor. So we can choose this A or B for my conversion factor, keeping in mind that I want to get rid of the minutes, but I want seconds left in my answer. So which one are you going to choose? Are you going to choose A or are you going to choose B? Well, A is going to be the conversion factor that is going to get rid of the minutes and keep the seconds. Now this guy right here is a defined quantity, so we're not going to look at it in terms of significant figures, but let's take a look at what happens to the units. Does everybody see how the minutes are in the numerator and in the denominator here, so they're going to cancel out, leaving me with the only unit I have left is seconds. Anytime you have numbers that are in the numerator, you're going to multiply them, and when I throw them in my calculator, I get 135 seconds. Okay, now to be careful and make sure that we have everything right, do we have the appropriate number of significant figures? Excuse me. How many significant figures are in this number? And there are 3 of them because they're all non-zeros. And over here, this one doesn't matter because there's definitely 60 seconds in 1 minute. And so my answer can have 3 significant figures. So I've got the 3 significant figures and I've got my unit. I'm ready to go. So you can check your work just by looking at what happens with the units. Do they cancel out? So let's take a look at this. I want to go from days to minutes. And when I go to days to minutes, I've got 2 conversion factors are required. The fact that there's 24 hours in 1 day and the fact that there's 60 minutes in 1 hour. So now let's take a look at this. Does everybody see how the hours does in fact cancel out, which is good. But what unit am I left with? Well, what are you going to get if you take a day times a day? And you're going to get a day squared. And what are you going to get if you divide it by minutes? You're going to get a day squared divided by a minute. So in fact, what do I have to do in order to make this correct? And you'll see that we're going to have to ultimately flip everything. So let's go ahead and try and do that. I'm going to erase this unit real quick. Let's start with what we're given. We're given 1.4 days. I want to get rid of the days. So in my conversion from days to hours, I'm going to actually put the day in the denominator so that the days cancel out and there's 24 hours. If I were to stop right here, see how the days cancel out? And my answer now would be in terms of hours. Whoops, oops. All right, so I'm going to multiply it times another conversion factor. And this one, where will I put the hours? Will the hours go in the numerator or in the denominator? It's got to go in the denominator because the hours is in the numerator, the prior conversion factor, times my 60 minutes. The hours cancel out. And now I throw this in my calculator. And I get 2016. So I get 2016 minutes. I've got my unit, but my significant figures is incorrect. So let's take a look at this. How many significant figures do I want in my solution? These are numbers that don't have significant figures. There's exactly 24 hours in a day. There's exactly 60 minutes in an hour. But over here we've got two significant figures, and I want two significant figures in my answer. But if I write 2,000 minutes, that will look like one significant figure. And that's where scientific notation can be useful. So if I put in 2.0 times 10 to the 1/2/3 minutes. I've got my unit. I'm showing that there's two significant figures, and we're ready to go. All right, let's take a look at one more. So we've got a rattlesnake, is 2.44 meters long. How many centimeters long is the snake? So always start with what you're given. So I'm given the 2.44 meters. And I want to know how many centimeters. Now, we're no longer in a place where you may have learned in middle school where some king did something and you could just move the decimals over. That will not be satisfactory in this class. You're going to have to show your work. And the reason for this is you're learning skills that are going to be beneficial, particularly when we start doing the mathematics of chemical reactions. So you need to look on the front page. There's a chart of metric conversions. And you know that there's 100 centimeters in a meter. So I'm going to put the centimeters in the numerator. So I have 100 centimeters in 1 meter. Now I very purposely put my conversion factor like that, even though I could have switched it. I could have had 1 meter over 100 centimeters. Why do you think I did that? Why did I set the 100 centimeters in the numerator? Well, that allowed me to cancel out the meters. And now what do I have left? I have centimeters. So if we multiply the 100 times the 2.44, we get 244 centimeters. Okay, I'm going to quit for right now, but on the next video, we're going to do some practice problems where there are two conversion factors, where you're going from one metric prefix to a different metric prefix. See you next time.